All right, let's get into it. Today, we are diving deep into something that can honestly make or break your cloud budget and, your performance. How to build systems on Google Cloud Platform that are efficient from the ground up, not just as some frantic afterthought. Okay, let's just nail this down right at the top, because this is the single most important idea we're going to talk about. Real lasting efficiency isn't about scrambling to optimize code right before a launch. No, it's a choice, a foundational decision you make right at the design stage before you've even written a single line of code. So here's our game plan. We're going to start by busting a common myth. Then we'll walk through a story of two different architectures. One gets caught in a really common trap, while the other is built on a modern cloud-native blueprint. And then we'll wrap it all up with a super practical checklist you can use on your own projects. Come on, we've all been there, right? We've all heard it. Just get it working. We'll optimize it later. But that whole mindset, it's a direct path to bloated cloud bills and systems that are just brittle. Today, we are flipping that script entirely. We're going to show how thinking about efficiency first is actually cheaper and way better in the long run. Okay, so let's jump into our story. I want you to imagine a team. They're building a brand new application, and they know their workload is going to be, well, all over the place. It might be dead quiet for hours, and then bam, a massive, unpredictable burst of traffic. They've got to be ready for anything. So what's their first move? Well, they follow the playbook they know. They spin up a bunch of virtual machines, they deploy their app, and, this is the key part, they configure enough capacity to handle the absolute biggest traffic spike they can imagine. And look, on the surface, this feels kind of safe, right? You're prepared for the worst. But the reality of this approach is, well, it's painful. Most of the time, all that expensive peak capacity is just sitting there, completely idle, literally burning money. And what happens when a spike goes that's even bigger than they planned for? It's chaos. It's all hands on deck, frantically trying to add more machines by hand. This isn't efficient. It's just expensive and super stressful. Okay, now let's hit rewind on that whole story. What if that team could do it all over again? What if instead of just lifting and shifting old habits into the cloud, they actually embraced a truly cloud-native blueprint right from day one? Let's see what that would look like. And this right here, this slide just lays out the massive philosophical shift. On the left, in the trap, you're paying for capacity you might need. You're paying for idle. On the right, the cloud-native way, you pay only for what you actually use, with the incredible ability to scale all the way down to zero. You go from manual panic to automated managed elegance. So how do we actually do this? The very first step is to completely rethink compute. Instead of those always-on VMs, our smart team chooses a serverless platform, something like Cloud Run. So now, when a request comes in, resources spin up instantly to handle it. And when the requests stop, it all scales back down, all the way to zero. That whole problem of paying for idle resources, it just vanishes. All right, let's talk about the next piece of this beautiful puzzle. In that old traditional story, all the services were probably calling each other directly, tightly coupled. The big problem there is if one service goes down, it can start a domino effect, taking everything else down with it. The cloud-native way is all about building resilient, decoupled systems that avoid this trap. And here's how it works, which is really cool. Instead of Service A calling Service B directly, Service A just fires off a message, an event, into a messaging backbone like PubSub. Then, a tiny serverless cloud function can listen for that message and do its job completely on its own. Now, if that function fails for some reason, no big deal. The message is still safe in PubSub, and it can just try again later. Nothing breaks. It's incredibly scalable and fault-tolerant by design. The last crucial piece of our new blueprint is data. In the old model, the go-to answer for pretty much everything was a big traditional relational database. But here's the thing about the cloud. One size absolutely does not fit all. And your choice of database has a massive impact on performance, on scalability, and on your bill. The key is so simple. Match the tool to the access pattern. You got classic transactional data? Cloud SQL is a fantastic managed service for that. Building a real-time web or mobile app with flexible data? Firestore was literally designed for that. Need to crunch massive analytical data sets with insane throughput? That is a perfect job for Bigtable. Getting this choice right is a huge win for efficiency. So, we've seen the two totally different paths our team could have taken. One led straight to high costs and constant operational headaches. The other? It led to a sleek, efficient, and scalable system. So now let's turn this whole story into a practical tool for you. I mean, just look at this. The difference could not be more stark. The total cost of owning and operating the cloud-native architecture is just dramatically lower. And remember, you're not just saving money on servers that are sitting idle. You're saving a massive amount of your team's time thanks to all the managed services and automation. Okay, so this is where it all becomes real, right? This is where theory hits the road. How do you make sure that you're starting on the right path and building that efficient blueprint from the very first day? Here it is. This is your design checklist. Before you start building any new component or service, just ask these simple questions. Is the traffic going to be bursty? Then you should be thinking serverless. Are your services all tangled up and tightly coupled? Use events to decouple them. Does your database really match how you're going to access the data? Answering these questions up front is how you bake efficiency into your architecture right from the start. So, if you only remember one thing from this whole explainer, let it be this. Stop treating efficiency like a cleanup task you'll get to later. It is a fundamental design principle. It needs to be your North Star from the very beginning of any project you work on. And I'll just leave you with this final thought. Just imagine, what if your next cloud bill wasn't just some scary list of resources you consumed? What if, instead, it was a true reflection of the actual value your application delivered to your users? That right there is the promise of a cloud-native, efficiency-first architecture. And it all starts with the blueprint.